All right, so we know when we talk about atoms and elements that it has something to do with protons, electrons, and neutrons, something along these lines. But as we've talked about, science and chemistry really develops by evidence being found, right? Chemical experiments, we analyze what happens with chemical experiments and we get to evidence. Certain evidence, then we analyze and we say, you know what, that probably means that this is what is happening. So what we're going to talk about today is really our evidence for how, for what we know about the atomic model, right? So we're going to talk about the evolution of the atomic model. So first off, an atom is going to be our indivisible unit. Right? It's an indivisible unit in chemistry. The reason being, there are some ways to break atoms down even further, but when we do that, it loses all of its features, all of its properties. Okay, so we're going to say that at this point, this is indivisible, and this was actually postulated, was theorized by ancient Greeks, but they didn't really have any evidence. Okay, the first person that really started to have some evidence was Dalton. So John Dalton in 1803, he's known as the father of atomic theory. Okay, and so what he did was he ran a few experiments himself and looked at what everybody else was publishing, and what he noticed was that, you know, sometimes maybe it was 1 gram of carbon and 1.33 grams of oxygen. Well, we could also have this resulted in some amount of a compound that they called carbon monoxide. Okay? If he had 1 gram of carbon and 2.66 grams of oxygen, they could react, and now they could form carbon dioxide. Okay? And so what Dalton was able to show, right, he analyzed this evidence, and when these reactions happened, he found that all of the reactions happened in specific ratios. And so what Dalton postulated was that there was some fundamental indivisible unit that was actually doing the chemistry. Okay? So he had this initial evidence, and then he postulated what might be happening within those atoms, right? So first off, he said, you know what? All matter is going to be made up of atoms. Okay? So everything that we talk about as matter, it's going to be made up of these fundamental pieces of matter, right? He also said that atoms of the same element are going to be essentially the same. Okay, so he said that, you know what, all of the ones that are this thing called oxygen, they're all about the same size, they all have the same mass, but they're going to be different from the ones that are carbon, right? So atoms of the same element are the same, but atoms of a different element is where they differ, okay? So they can be different from other elements. But he also said, you know what? There's no way that we can create or destroy atoms. Atoms cannot be created nor destroyed, okay? This was something that when he looked at this experimental data, said, you know what? When I had 1 gram of carbon, 1.33 grams of oxygen, I'm always getting 2.33 grams of oxygen out the end here, right? we have the same mass going in as we get going out after the reaction, okay? Now, he also said, well, if I look at something like this, I know that I get this ratio here, and when I do a different experiment, I get a slightly different ratio, even though I have the same elements, right? This one is C and O, this one is C and O. So what he said, I'm going to have to go down on the bottom here because I didn't plan very well. He said elements can combine in different ratios, but it has to be whole numbers. So elements combine in whole number ratios. Okay? But, of course, they can have more than one variations, right? They combine in whole number ratios, but they can vary. So we have CO and we have CO2, okay? And he also said then that atoms, it's the smallest unit. It's the smallest unit that keeps its properties. Oops, I'm just going to go prop. All right, so atoms are the smallest unit that keep its properties. All right, so what Dalton did was he said, here's this evidence, and I see that always, always, always combines in a ratio, and that ratio, if I limit it, it's going to be a whole number ratio. But that ratio can change, right? We can have 1 gram of carbon combined with 2.66 grams of oxygen, and I'm going to get CO2. But if I have 1 gram of carbon and 1.33 grams of oxygen, I'm going to combine it and get CO. All right? So this piece really, the reason that Dalton is able to hypothesize that this is what's happening is because he looked at his evidence. Okay? So, a little bit later, we're going to talk about J.J. Thomson now. J.J. Thomson used a cathode ray tube. And so what he did was he had a tube that was kind of evacuated, right? So it didn't have really much of anything in it. And he shot some sort of particles through it. And then he took a magnet, he took a magnet and he said, we're going to put a plus up here and a minus down here, right? Magnets have their ends. And what he saw was that he was able to bend that beam, okay? So when that beam gets bent, it must be that it's interacting with the magnet, okay? And so what he hypothesized, oops, this should actually, I'm going to flip this and say that this is my positive end and this is my negative end. So what he saw was when he shot this ray of beam, or this beam through here, was that it ended up getting bent towards the positive end. And so this ray was part of an atom. It was some part of it that was getting bent away or from the negative end and towards the positive end. Okay? So when he saw this, what he said was, you know what? Atoms have to have multiple parts. He said one part that he was kind of blocking has a positive part, right? The positive is getting blocked over here. It's not getting shot through. And then we're going to have a negative part. And the negative part is what's getting shot through here, and it gets attracted towards the positive end. Okay? So what he came up with was, he said, you know what? If we have these positives and negatives, I'm going to say that atoms, rather than being a big ball, right, really they are kind of divisible. We can actually break them down in a little bit. And so what he hypothesizes is that it's a plum pudding. Okay? Plum pudding, you may not know if you haven't been watching the Great British Baking Show, but it's kind of like a chocolate chip cookie, too. You've got positives and negatives all kind of mixed in, right? We got positives, negatives, all mixed in here throughout the atom. All right? And it was based on this experiment. He saw that this cathode ray, right, this negatively charged ray was getting bent towards the positive end of the magnet. All right, so we're going to pause there and go on to the next page in a second. All right, so what I forgot to say here, right, why did Thomson know that there has to be positives and negatives? Well, we said that just the negative particles were getting shot through on this beam, and so they got attracted to the positive end. But Thomson knew that overall, atoms don't have a charge, right? Atoms and elements and compounds, whatever we have, that doesn't have a charge. So he knew that within the atom, if we're getting out these negative pieces from the atom, that those are negative, then there has to be a positive to balance it out. All right?